Well, just today when I needed to start writing, my iPad broke, my Apple Pencil broke. I don't have a whiteboard, but I do have a cupboard, and I have 2 pens, so I'm going to try writing something and let's see if it makes any sense. Gradient descent is really very simple. Imagine you're on some kind of hill, and you want to reach the bottom of the hill. You want to reach over there, and you're over there somewhere. Well, all you do is you find which direction is up and you move in the opposite direction. That's all there is to it. The one thing you have to watch out for when you're doing gradient descent is how big the steps that you take are. If you take really small steps, it's going to take you a very long time to reach the bottom. If you take absolutely huge steps in that direction, so if you try taking a really huge step in that direction, you might go all the way to the other side, and if you're not careful, you might actually end up further up in the up the other side of the hill. So taking huge steps is not a good idea. What does this mean as far as maths is concerned? Well, finding which direction is uphill means finding the gradient. So if you have a function, you're going to have to differentiate it. But let's say you have differentiated your function and the gradient is given by g, and you've decided you're going to take steps, some step size eta. Then imagine you start off at some point x, then x1. What we will do is we will start at x0, and we will take a step of size eta in the opposite direction, which is why we've got a minus sign over there, of the gradient. So here we have the function y equals x squared, starting at the point x0 equals 2, and we want to somehow find the minimum of this particular curve. Now, what do? We find the gradient, dy by dx equals 2x, which means the gradient at x0 is equal to 4. x1 equals, start off with x0, which is 2, minus the step size, let's take 0.1 this time, times the gradient, which is 4. That will leave us at 1.6. So now what do? We're still not at the minimum. Well, it's very simple. We just do another iteration, this time starting at 1.6. Starting at 1.6, we have x2 is going to be x1, which was 1.6, minus the step size times the gradient of 1.6. The gradient at 1.6 is going to be 3.2, which is going to equal 1.6 minus 0.32, which is probably 1.28. So we've taken the next step and we've moved closer to the origin. What do? We just carry on going and going and going until the target function doesn't get any smaller. So what does the whole algorithm look like? Well, we start off by initializing x0. You can possibly initialize it at random or do something more sensible, and you set an index to 0. Now, while you have to carry on going because your target function is not as small as it needs to be, then find the gradient. So find gradient at x I, and then x I plus 1. So that's the next value of x that you're going to try is the current value minus the step size times the gradient. And that's it. You have to decide when you're going to stop. You'll probably decide to stop when the changes in your cost function should be getting smaller each time, and at some point the change in your cost function won't be very big, and then you'll stop.